Problems involving probabilities. Let's look at an illustration. Suppose that the probability of recession next year is 30%, and the probability that interest rates will go up given that there's a recession next year is 21%. So first I'd like to point out how the practice is to express these probabilities. So when you see this sign over here, it means given, and this is referred to as a conditional probability. And the way to read that is the probability of interest rates going up given that there'll be a recession next year is equal to 21%. At the same time, the probability that interest rates will go up given that there'll be a boom or an economic expansion next year is 78%. And again, the way to read this is probability that interest rates go up given that there's a boom next year is equal to 78%. So what framework do we want to use here? In this case, the outcomes are mutually exclusive. For example, interest rates cannot go up and down simultaneously. Similarly, the economy, it can't be in a recession and an expansion at the same time. So when the outcomes are mutually exclusive, we use a probability tree. And here it is. So here's our framework. Now, the way we set this up is as follows. We start with the independent event, and that'll affect the dependent event. And the terminology that's used for independent event is that it's the unconditional. And that's what independent is. So it doesn't need any conditions. It just occurs by itself, whereas the dependent variable is conditional because it's conditioned upon what happens to the independent variable. Now, it's actually not up to us to determine which is the independent or which is the dependent. It's actually embedded in the question. So if you look at the question carefully, it says probability that interest rates go up conditional upon there being a recession next year. So what they're saying is that the recession or the state of the economy will occur first, and then interest rates will react accordingly. So that's where we get our cues from. So there it is. The independent event is the economic cycle, and the dependent event is what happens to interest rates in response to what's happening to the economic cycle. So the way I like to lay this out is as follows. I like to start off with 100 units, and I just want to see where these 100 units end up. And what I mean by where they end up is, did they experience a recession? Did they experience a boom? Did they experience an interest rate increase or decrease? So let's start populating this table, or this tree, I should say. So first of all, we were told that the probability of a recession is 30%, okay? So there it is. Probability is recession of 30%. So out of the initial 100 units, 30 end up there. Done. Now, they didn't give us a probability of a boom, but we could figure that out ourselves, right? So if we have 100 units here and 30 went here, that means the other 70 went to the other outcome, which is an economic expansion or a boom. Perfect. So now what we do, ladies and gentlemen, is we pick up the analysis from these nodes. So the economic event has happened. Now let's see how interest rates respond. Let's look at the information that's given to us. They told us that the probability that interest rates will increase given that there's a recession is 21%. So it says given that there's a recession, so now you're here, right? It says, so a recession has occurred. So if a recession has occurred, we're here. It says, okay, now that 30% or that 30 units, 21% will experience a rate hike. So, okay, 30 times 21 right there gives us 6.3 units. Now, when you get to this node, what has happened? Well, you first stopped at that node, and then you ended up at that node. So both events have occurred. So that's why it's referred to as a joint probability, because by the time you get to this node, we've had a recession and interest rates increase. And we're going to do the same thing for all of them. And so let's just complete this branch. Now, we know we have 30 units here, ladies and gentlemen. And we know that of those 30 units, 21% experienced a rate hike. Now, the question didn't give us the probability of a rate decrease, but that's okay. We could figure it out ourselves. because every node must be fully accounted for. In other words, the probabilities of the branches must add up to 100%, and this is what I mean. Right? So if 21% of that 30 experienced a rate hike, then it goes to reason that 79% of that 30 experienced a rate decrease. So by the time you get to this node, again, what has happened? Well, we got to this node from this node, so a recession has happened. And what else? Interest rates have decreased. So that's why this is referred to as a joint probability. And just very quickly, let's just finish up the tree. So we know 70 units ended up here. That represents a boom. Let's see what data was given to us. We were told that probability of interest rates increasing given there is a boom is 78%. So given there is a boom, so now I'm here, right? And that's the key to using this tree, ladies and gentlemen, is you have to identify what point the question is referencing. So from where am I looking out? And if they say a boom has occurred, I am right here now. So the probability of interest rates increasing, given there is a boom, is 78%. So of the 70, 78% would experience a rate hike. So by the time you get here, both events have occurred. In other words, there's been a boom and interest rates have increased. So therefore, this would be a joint probability. And then when you get here, of course, a boom has happened and interest rates have decreased. And that works out to 15.4% joint probability of boom and rate decrease. Now, the beauty with using this framework, ladies and gentlemen, is the following. The initial 100 units you started off with are fully accounted for. And that's exactly what you want. So now that we've constructed this probability tree, we can answer a whole bunch of questions, right? And there's the tip, which I discussed previously. Identify the node the question is referencing. Okay. So the first question says probability that interest rates decrease given there is a recession. So recession has occurred, so I'm over here. Okay, what do you want to know? If you're standing here, what's the probability that you'll see an interest rate decrease? 79%. So that's referred to as a conditional probability, as I referenced before, because it's saying what's the probability that interest rates will decrease given, i.e. conditional upon there being a recession. Let's look at the second question. It says, what's the probability that interest rates will decrease and there will be a recession? So this is a joint probability because it's saying what's the probability that both events have occurred? Well, for both events to have occurred, you would have to be, let's see, that says interest rates decrease. You would have to be right here. Because if you're there, both events have occurred. You've experienced a recession, and over here you've experienced a rate decrease. So if I'm here, what's the number I'm looking at? 23.7%. So that's really the key, is just identify which node the question is referencing. Let's look at another question. What's the probability that there'll be a boom and interest rates increasing? So this is joint. So both events have occurred. So I would be at the rightmost end of that probability tree. So boom. So that's a boom. And it says rate increase. So I'd have to be here. So where am I, or where's the question referencing? The question is referencing right there, because if you're at this node right here, you've had both a boom and rate increase, and the probability of that happening is 54.6%. And just very much similar exercise, recession and interest rates increase. So if you want recession, here it is, but you're saying and interest rates increase, so I would have to be here. So this is where I am, and at that point, the probability of both these events occurring is 6.3. So now what they're asking is, well, what's the probability that interest rates will increase? So let's go to our table, or tree, if you will. They're saying, what's the probability that interest rates will increase? So which node are we looking at? Which nodes represent interest rate increasing? It's nowhere here, right? Because that's just talking about the economy being in recession or boom. So if you're looking for interest rates increase or decrease, you'd have to be all the way at the tail end, because these events, by the time you reach those nodes, it's also embedding what happened to interest rates. But it's only asking for interest rates increase. So therefore, I'm interested in this node and that node. So those two nodes represent interest rate hikes. So you just add them together. 6.3 plus 54.6. There it is. So it'd be 60.9. Now this would be referred to as an unconditional probability. And here's why. Because it's just asking for what's the probability that interest rates will increase without any conditions. So it's not saying interest rates increasing dependent upon there being a recession, or, I'm sorry, not that one. So this here is conditional. See, it says it's conditional upon recession. So when you just see probability of interest rates increasing, it's unconditional. Now in the sixth question, they're going to turn the tables. They're going to say, well, what's the probability that we're in a recession given that interest rates are increasing? So this is referred to as a posterior probability. And this reverses the order of the dependent and the independent variable. Because if you look at our probability tree and the way the initial question was set up, it said the recession would occur first, and then we would see if what's happening to interest rates. But here it's saying what's happening to the economy given that you see interest rates going up. So it reverses the pattern. It says if interest rates go up, what would be the probability that we're in a recession? And there it is. So originally, the state of the economy would affect interest rates, but now it's reversing. It's saying if you see what's happening to interest rates, what can you tell about the economy? And this is basically what Bayes' theorem is. And ladies and gentlemen, I can't help but share with you some real-life example. You know how traders are always watching the Fed, the Federal Reserve, the central bank? And that's exactly what this is alluding to. It says if you see the Feds changing interest rates, can you work backwards and sort of determine what the central bank thinks is happening to the economy or which way it's heading? So there's a lot of real-life implication in this. So when traders see that the Federal Reserve or the central bank is raising interest rates, that's sort of a warning sign that they're trying to cool down the economy moving forward. So there it is. Now our task is to figure out what the answer is for this conditional probability or posterior probability. And by the way, it's still a conditional probability because every time you see this sign, it means it's one event is conditional upon the other event occurring. So first we start with this guy, interest rates going up, because that's the first event, right? They're saying given you see what's happening to interest rates, well, what is the probability of interest rates going up? So based on our observations that interest rates will go up, how does that change the probability that recession will occur next year? And that's just explaining this in more depth. And here's the process. So first, let's determine what's the probability that interest rates will go up in the first place, right? So again, we're trying to solve this guy. Well, it's 60.9. We calculated from question 5, right? It's over there. Now, that 60.9, part of it came from boom, and part of it came from recession. And again, ladies and gentlemen, I just want to show you where that's coming from. So where did that 60.9 come from? There it is. This was from the boom, and this was a rate hike coming through recession. So then now we have to find out the proportion of the 60.9 that's attributed to a recession. And that's it. So 60.9 is the total probability of interest rates going up. And what portion of that was a recession? 6.3. So 6.3 out of 60.9 works out to 10.34%. So then how would we interpret that? So first of all, Absence any new information, the probability that there'll be a recession is 30%. I just wanted to bring you back to the tree to see where all this is coming from. So if there is no information, our best estimate for the probability of recession next year is 30%. But here's what the posterior probability says. It says, well, what if you observe the central bank changing interest rates? How would that change your outlook for recession next year? And that's what this says. So it says, based on new information, i.e. Seeing the central bank raising interest rates, now our outlook, or the probability for recession next year, would only be 10.34%.